Victoria by the Sea is quite tiny. It has about 75 full-time residents and primarily a tourism village. We do have some fishing and some farming. This is in Northumberland Strait, and Victoria is in the middle of PEI.
Because of the sanitation problems in the core area of the village, development was totally halted. Building permits weren't being issued, so new homes couldn't be constructed, businesses couldn't expand until the sewage problem was dealt with.
75% of the lots were not up to standard size where you could have on-site sewage.
They basically had septic systems and holding tanks throughout the village, and most of those systems were undersized, overloaded, failing, malfunctioning periodically, or in the case of holding tanks, they would need to be pumped out very frequently.
You would have septic tank trucks pumping out different people. It might be a steady stream of them every day, a different one coming in. And once you open a tank to pump it, there's a certain odor that pervades the neighborhood.
That sewage that they were pumping and hauling away had to be trucked into Charlottetown. We did calculations to determine that greenhouse gas emissions will be reduced considerably as a result of the implementation of the project.
The only solution was to have a central sewage system.
We compared many different conventional, traditional sewage collection and treatment options with some innovative alternative solutions.
But our challenge with that was that we have beautiful water right there that we swim in, that we harvest shellfish out of, that we particularly enjoy. And most systems have an outflow, which would involve some of your discharge going into your local water.
I recommended to the community that we look at what's called a land-based effluent dispersal system as an alternative to a direct discharge.
Everyone's yard was dug up. You know, this went on for a whole summer. It looked like, no man's land through here.
Because of the poor surveying that was done when these lots were laid out, people's homes were actually technically in the street in some cases, or their front yards were technically in the right-of-way.
And you had to dig a huge hole, put in a concrete tank below ground, fill it all back in, connect the houses up, try to replace some of the landscaping, and then resod everybody's yard.
And so that required a lot of coordination with homeowners and business owners. And the village was very wise in hiring a capable project manager to make sure that the homeowners were happy with where things were located, and that everyone was communicating on about what had to happen, the schedule, and so on.
And the villagers were very supportive.
The effluent now leaves their property, goes out into a series of collection lines out in the street, but it still gets that primary treatment first on their property in the form of this septic tank. The tanks that we put in have much more capacity than a traditional septic tank. They were tested to ensure they're watertight, and that provides an important first step in the treatment process. Those tanks really should not need to be pumped out any more often than probably once every 8 to 10 years for a year-round home. So the maintenance should not be very onerous for the utility. Every septic tank has a high-level alarm, so if there was a high level in the tank, it would sound an alarm, just like that.
It's all gravity fed, except for a couple of instances where they're kind of below the level. But the water runs to the lowest point in the community, which is where the lighthouse is, and it's a iconic structure. It's an important aspect, but it also was where we put our pump station. And there's 3 pumps in that pumping station. They're 1.5 horsepower pumps, so they're a fair bit smaller than a lot of larger city systems, where we don't have a lot of solids in the system that require more powerful pumps. Then there's also a few homes that were too low to gravity flow into that pumping station, so they have their own individual pump in their septic tank. The effluent from those tanks pumps directly into the force main, which comes up here to the treatment site. There's no odor down there whatsoever. There's no sound. You wouldn't know anything was going on. Effluent from all the septic tanks in the village
is pumped up here to the wastewater treatment facility and goes into one of two large fiberglass tanks. These tanks are referred to as recirculation dilution tanks, so they serve a couple of purposes other than just providing a place to put the pumps. The effluent is pumped onto the treatment modules, and the effluent makes several passes through the treatment modules.
All the wastewater is treated and the bacteria has a go at it.
Every time the pumps pump the effluent into the textile pack bed filters, it trickles down through, gets partially treated, and drains back to these big recirculation dilution tanks. It's in single hanging sheets in the pods and the modules, and it can be just lifted out, hosed off with a garden hose, and put back in. So it's much less risk for the community if there was an unforeseen overloading incident. So it goes through a minimum of 4 times through that process before it's ready for final dispersal.
Bacteria does all the work. There's no chemicals involved. So you just sort of maintain an environment for them, and they'll do all the cleaning up of your water.
It's certainly treated to a high enough quality that it makes it very easy to put that into the ground, into the soil. There's 2 systems here for effluent dispersal. One is similar to a conventional drain field, and it essentially serves the winter time flows, which are much lower than the summertime flows. And then for the peak summer period, we have about 1.25 acres of area just downslope of the area where the treatment modules are, where we have a subsurface drip irrigation system.
Not one drop of wastewater ever goes anywhere except back into the ground as clean water.
Even though the sewage treatment system and the land dispersal system are removing a very high amount of the nitrogen that's in the effluent, there still would be some. PEI is 100% reliant on groundwater for drinking water, so a location had to be found where that nitrate would not negatively impact on the groundwater supplies that Victoria draws from for its central water system. We have a number of pumps in the system. We have some fans, so the control panels determine how often the pumps come on and for how long they stay on. The control panel is equipped with advanced remote monitoring capabilities.
The monitoring of the system was really attractive to us as well, because it's all there's a computer that runs everything and gives you real-time information of what's the status of your pumps and how many gallons.
And also if there were a problem with the system, if one of the pumps broke down or there was a high level in one of the tanks, it will set off an alarm and notify the operator. Having those that remote monitoring capability and telemetry features means that Victoria doesn't have to have a full-time operator, and the operator really only has to come here to see if respond to a problem and to do routine scheduled maintenance. So it really cuts down on the maintenance costs. We hired a consultant from the US actually to work with us remotely. He was a pioneering engineer doing these types of collection system projects. Mistakes were minimized and nothing major was missed. As part of the project, we wanted to encourage people to conserve water, and one of the best ways to do that is to charge them for what they use. Victoria offered a program whereby they covered the cost for one replacement toilet for each home, and all the businesses retrofitted all of their toilets with low flow.
This is a $2.5 million project, and we're got 50 users that are feeding into it. Because it's innovative, the Green Funds were able to help us with our share. The federal government pays a third, the province pays a third, and the municipality's third thankfully came from the Green Funds. Otherwise it never would have happened here. It just wouldn't have been financially possible.
It was a little difficult to compare before after because the community immediately started growing and developing and expanding, but nevertheless we did see an overall reduction. In spite of that growth, there was still a measurable overall reduction in the water consumption before and after the project.
Over on the west side of the village we have a subdivision with 26 new lots, and every lot will have a connection to our wastewater system and to our village water. So it is growing in a manner that wouldn't be possible if we hadn't gone ahead with the wastewater treatment.